Hello everyone, welcome to my channel Math with Mrs. O. I'm Ofelia Orate, a principal owner of a school, a math teacher, and an author of 21 books. Our lesson for today is Maxima and Minima problems from the quadratic functions. First problem, the sum of two numbers is 10. What is the maximum or the largest possible product? And what are the numbers? Okay. Let me explain to you first the long way so that you can compare what I'm going to do later, introducing to you the short way later. Let us say we have the following numbers here. A to be the first number, B is the second number. The sum must be equal to 10. A plus B, this should be B, A plus B, sorry. And we want the possible product, so A times B. Let's tabulate first. Let us say your first number is 10. So your second number is 0. Why is 0? Remember, the sum of the two numbers is 10. So 10 plus 0 is 10. Multiply 10 times 0 is 0. Now, if we take this to be 9, if we let A, our first number, to be 9, our second number is 1. 9 plus 1 is 10. What is the product? 9 times 1 is 9. Let's skip to make things fast. If we let our first number be 6, this is going to be 4. The sum must be equal to 10. So the product, 6 times 4 is 24. Let us say we get another number 5. What is the second number? The sum must be 10, so the second number must be 5 also. 5 plus 5 is 10. 5 times 5, which is the product, is 25. Now, let's try another number, let's say 4. But we already have a 4 here. So let's try another one. Let's make it 3. 3, the sum must be 10. So this must be 7. 3 plus 7 is 10. 3 times 7 is 21. Let's try another one. Let's say this is now 2. 2 plus 8 gives us a 10. And 2 times 8 is 16. Now, what if we try 1? 1, this is 9. 1 plus 9 is 10. And 1 times 9 is 9. There. Now, the problem is asking for the maximum or the largest possible product. Let's take a look at the products here. What did you observe? You have 0, and then 9, then 24, then 25. And then, when the numbers here were going down, did you notice that the product here are also going down? Let us say we insert another number here. Let's say instead of 9, let's put here a 7. So the next number will be 3. The sums will still be 10. And 7 times 3 is 21. See? So what did you observe? The numbers here are increasing. And the biggest is 25. There, this is the biggest or the largest product, whereas the numbers here are decreasing again. So we have seen that the largest product is 25. But we cannot always go on like this, using a very long way, tabulating all the possible numbers. Because what if the problem is asking for the sum of two numbers, which is, let's say, 100. So you will have so many numbers in the table. So therefore, there has to be a way of solving such problems easily. And that is given by algebra using the quadratic functions. Specifically using the vertex of the quadratic function. Why do we have to use the vertex? Because if the parabola is opening upward, the vertex here gives us the minimum or the lowest value. The y value of the vertex gives us the minimum or the lowest value. And if the parabola is opening downward, as you can see, the vertex here will give us the maximum or the highest value. There. So therefore, to take a shortcut in problems like this, all we have to do is to find the vertex. And in our other videos, we already used the vertex formula, which is given by negative b over 2a for the x value. Remember, this is the x value of your vertex or your h. And 4ac minus b squared all over 4a, this is the formula for the y value of your vertex. So therefore, if we have problems like this, we just have to use the vertex formula. Okay, let's start again. The sum of two numbers is 10. So we let a be the the first number, and we let b be the second number. And the sum of the two numbers is 10. So a plus b is equal to 10, giving us a is equal to 10 minus b. What is the maximum or largest possible product? So if we let a be our first number and b be our second number, we will be having here the product. Our product is a times b, but we learned that a is equal to 10 minus b. I have to erase this. A is 10 minus b, so we substitute the value here. 10 minus b for a times b. That is your product, or you can let this be your y or your f of x. Others might use f of x here. That's okay. So we simplify. So y is 10 times b is 10b minus b times b is b squared. Can we rewrite this as negative b squared plus 10b? Yes, the answer is yes, by commutative property. So now this is in the form ax squared plus bx plus c, where your a is here. This means that you have a negative 1, where your a is negative 1. Your b is positive 10. And c is 0. The problem is asking for the numbers, so we can solve for the x value of the vertex. So our x is now equal to negative b over 2a, which is now b here, substitute value, negative 10 over 2 times negative 1. That gives you a positive 5. So the numbers are 5. If one number is 5, the other number must be 10 minus 5. So we have here, the numbers are 5. 5, 5. And let's write here, the numbers are 5 and 5. Next question. What is the maximum or largest possible product? So we now use 4ac minus b squared all over 4a for the maximum product. Their maximum product. So substitute the values, we get 4 times a negative 1 times c 0 minus b squared minus 10 squared all over 4a, 4 times negative 1. There, we have here, this becomes 0. So you have 0 minus 100 all over negative 4. There. So you have here, 100 divided by 4 is 25. So we can write here the maximum or the highest, the maximum or the highest product is 25. Let's just have a recap. So, have you seen that we tabulated here the numbers, and we have seen that when the numbers are 5 and 5, the product is 25, which is the maximum product. And then when we use the vertex formula, the x stands for the number. In this case, we let it be a. So we solve for negative b over 2a. Just substitute the values of negative b over 2a here. We also got 5. And 10 minus 5 gives us a 5. We simply let x here our number, which is in this case our b. Just so you will not get confused. And then the y value of your vertex is the product. Remember when we formulated the equation here, we let the product be f of x or y. So the product is y. It is given by the y value of the vertex formula, which is 4ac minus b squared over 4a. There, just substitute the values and you get the same answer, 25. Let's move on to our second example. Problem number 2. A rectangle has a perimeter of 200 centimeters. What are the dimensions? When we say dimensions, we're referring to the length and the width. The length and the width. So we're being asked about the length and the width. So what are the dimensions of the rectangle if the square of its diagonal is a minimum? So we know that 2 times the length plus 2 times the width equals 200 as given by this. Perimeter is 200 centimeters. So we let L be the length and we let W be the width. There. So the perimeter is 200. 2 times the length plus 2 times the width is 200. we can simplify this. So we can have here an L plus W equals 100. That's our first equation. Next, what are the dimensions of the rectangle if the square of its diagonal is a minimum? Let us draw a rectangle. There. So this is your W. This is also your W. This is going to be your length. But here, as you can see here, the L is equal to 100 minus W if you transpose W to the other side. So we can write this as L equals 100 minus W. And then it says here that the square of its diagonal. So let's draw the diagonal here. This is the diagonal. And we would like to get the square of the diagonal, so we let it be d squared. So we let our y, or our function, if you're using f of x, equals the square of the diagonal, is a minimum. So, since this is a rectangle, you know that this is 90 degrees and this is 90 degrees. And you now have here a right triangle. So you can apply the Pythagorean Theorem here. So we have here the square of the diagonal for our y is equal to W square plus the square of 100 minus W, quantity squared, using the Pythagorean Theorem. Simplify this, so this is y equals W squared plus, this is now 100 squared minus 100 times W is 100 W times 2, that's 200 W plus W squared. If you're having a hard time doing that, then you can do it the long way. 100 times 100, that is 10,000. 100 times negative W, that's negative 100 W. Negative W times 100, that's negative 100 W. Negative W times negative W is W squared. So you end up with 10,000 minus 200 W plus W squared. There. So here, I took the shortcut, square 100, multiply this to 100 W times 2, so that's 200 W, and square the second term, W is W squared. So simplify them, W squared plus W squared gives us 2W squared minus 200W plus 100 square, which is 10,000. There. Now, the problem is asking for the length and the width. So, n such that the square of the diagonal is a minimum. So let's just check. The value of a is positive 2. We know that when the value of a is positive, the graph of the parabola of the quadratic function or the parabola opens upward. So we have a minimum. So that's the first checking. So our equation is correct. Now, the minimum occurs at the vertex. The minimum occurs at the vertex. So we have here h and k, but we are only interested in solving for the h. The h is the length or width, okay, the width here, and the k stands for the minimum value. So we have to solve for the h. And the vertex formula is negative b over 2a for h, 4ac minus b squared over 4a for k. But are we interested about the minimum value? No. We're just interested about the dimensions. So we only have to look for this value. Substitute the value. So a is 2, b is negative 200, C is 10,000. Substitute the value, so negative B, negative of negative 200 is positive 200 over 2A, 2 times 2. There. So this is 200 divided by 4 is 50. So the width is 50, let me see the dimension, centimeters. So if the width is 50 centimeters, what is the length? The length is given by there. So this is the width. The length is given by this formula, 100 minus W, or 100 minus 50. So we have here 50 centimeters. There. Before we end, please don't forget to subscribe and click the bell button. And always remember to add kindness, subtract judgment, multiply understanding equals Mrs. O's good life equation. Thank you and God bless.